Hello, friends on LinkedIn from around the world. Thanks for joining me once again for Demo Days. There's a common notion that application security is a job for your organization's security team, but the truth is that you don't have to be a security researcher to significantly impact the security of your applications. Last week, we talked about one practical step, that of using hardware security keys to secure your GitHub account. Today, we're going to look at a few more steps that every developer can take to mitigate security vulnerabilities. And to help me with that today, I've got Glenn Wester, Senior Solutions Engineer over here at GitHub. And I've got also Rob DeRosa, who's a Principal Solutions Engineer, and he's in the LinkedIn chat if you have any technical questions. So if you find any of today's chat particularly useful and you want to get a demo specific to your organization's context, feel free to use the QR code that I'm going to pop up in just a bit and book a meeting with us. With that, Glenn, could you take it away?
Absolutely. Thanks, AJ. Let me share my screen here. Okay, cool. We're going to get things kicked off here. So hopefully everybody can see my screen. Welcome to the demo day. As AJ mentioned, I'm Glenn. I'm going to be your captain for today's session. I'm fully aware that it's demo day and not slide day, so I promise no slides. So let's check out the agenda. I'm going to do a cool directory style agenda here to be extra hacker. So what I want to do with you today is I want to implement security in 30 minutes. I think sometimes we make shift left and implementing security into this big mountain, when in fact it's pretty simple. And GitHub has made significant improvements to its security offering to help you do that very quickly. So this is exactly what I want to do with you today. Is over the course of 30 minutes-ish, is I want to show you by the end of the session how you can implement security in addition to some of our advanced security offerings. So first and foremost, we'll look into secret scanning. This is if you check in a token or a known password. We want to make sure that we capture that before it becomes a problem. We'll get into code scanning with our static code analysis offering called CodeQL. There's also source code that we can't control, like in modern enterprise software development, that comes in the form of open source. GitHub is very qualified to educate you about the open source that you're consuming and what vulnerabilities it might contain. And then, of course, too, across our organization within GitHub, we want to find out what's the state of security, how many repositories have things enabled, and what are we catching. So that's what we'll cover in the security overview. If you have any questions as I'm presenting, please type them into the chat box, and either Rob will interrupt me or we'll take them at the end. And please feel free to ask away. Okay, with that, the first order of business that I just wanted to capture really quickly, logistics-wise, is that we have a conference coming up. For those of you that are familiar with our conferences, we have 2 per year. We have Satellite, which is more European time focused, and then Universe, which is at HQ. So that will be Pacific time. If you want to sign up and see any updates from GitHub Universe, just go to githubuniverse.com. And yeah, we'd love to see you there. We have a lot of great talks and getting really excited for it. Okay, cool. So let's just quickly review. So this isn't a slide. This is a photo of a slide. It's a JPEG. It's not a PPTX, I just want to review very quickly the state of security for GitHub. So of course, there's code that we can control. We call this securing the software supply chain. They are the components that go into our application that then we ship to our end customers. But then also too, there are things that we are in control of, meaning that the code that our engineers are writing, we can scan that and make sure that it's high quality before shipping to our customers. And then we also secure this with the development lifecycle. So of course, the buzzword is DevSecOps. We want to move this into development. I'll get into reasons why that's very good to do and gets vulnerabilities on your developers' radars much earlier, which is better for everybody. So the first thing based on the agenda is that we want to get into secret scanning. So let's jump into that. So for those of you uninitiated, this is something called the GitHub Enterprise account. GitHub has 2 core offerings for our enterprise. We have something called GitHub Enterprise Server and GitHub Enterprise Cloud. What I'm showing you is Cloud here. It's a fully managed offering where we can combine many different GitHub organizations into one kind of parent account called an enterprise account. This lets us apply policy and security over all the organizations that we manage. I just want to make you aware too that if you want to do this stuff on-prem, you can. We have a local github.com called GitHub Enterprise Server. You can fully air gap it. It's a virtual appliance that you install locally behind your firewall, and people can use it, and you get to have complete control over it. So it's not managed at all. You'll be standing up a server and maintaining it and doing upgrades. And a seat of GitHub Enterprise, if you're using this for work, we'll give you a seat on both. So we don't care which one you use. I just want to make you aware of both offerings. So secrets, this is something that impacts everybody. Working with the enterprise customers in the West here, I get to work with some of the largest companies in the world. And I would say we see this happen all the time. It's not like just something that junior developers do. We see people that have been developing software for 20 years commit a secret accidentally. And the objective here is to not hire people that don't do that, because good luck. What we really want to do is that we just want to check. We want to make sure that we're not committing secrets, which can become problems like down the line. If somebody's savvy enough to decompile your application, they might be able to scrape that password in plain text. Or if somewhere down the road, if we get acquired or something like that, and we want to make our source code open source, that secret might become a problem then. It's just not a good idea. We want to put it into proper encrypted storage. So we want to be aware of what secrets exist within our code base. So within this enterprise account, of course, I can click into an organization, set this up, but I just wanted to show you at a higher level that we can use this enterprise account, and we can go into the Advanced Security tab, and we can go to security features, and we can look at the custom patterns that we're defining for secret scanning. Now, secret scanning for private repositories works in two ways. We're scanning for known tokens from known providers. We have something like 125 different providers that we're looking for. So kind of like the most popular services that you possibly want to use, we're scanning for. What we do is that we partner with these companies and we find out the signature of their tokens and secrets. So that way we know how to identify them. And by the way, if you work for a company that has a lot of tokens and you see them on GitHub, send us a mail. We can sign you up for our partner program, and we're constantly adding new providers to this. So in addition to the providers that we know about, so this is something that we're scanning for by default. And if you ever want to see the list of providers, I'll have Rob share the link to the channel there. In addition to the providers that we know about, there will also be token formats and other things that we want to scan for custom within our code base that might be unique to our business or organization and to our entire enterprise. Let me just show you a quick example of how this looks. So in this case, I just have a little bit of regex written. In this case, we want to make sure that we're not committing any IP addresses. Now, this might not be super high profile. Like maybe you'd want to put a token in here or other passwords that you want to be looking out for. What's really cool too is that within this dialog box is that we can test this as well. So if you do want to see 169.168, we can see that we're matching very quickly based upon this regex pattern. And again, this is completely customizable. Right now, we're setting this up at the enterprise account level. What happens is that if this condition is met, you'll get an email saying that you committed a token, and then you can choose a method of remediation. Meaning in private secret scanning, we're not going to do any automatic remediation because you might want to vary what you're doing with that actual token. Either putting it into encrypted storage or removing it completely or using some other mechanism. Let me show you how this looks too within an organization. So an organization, of course, is where our repositories are going to be. If we click into settings and we go into security and analysis, we can see here that we have secret scanning. And in this case, we're doing an email check. In this case, we want to make sure that no one's committing their email address into our source code. Again, you can put token formats in here or secret formats, and you can always test it before implementing it. Okay, so let me show you how it looks too when we're actually finding secrets. So let's just say that we did find some secrets that were being committed. So what I'll do over here is I'll go into the security tab of a repository. The security tab too is going to contain most of what we're talking about today. So Dependabot, code scanning alerts, and here we have secret scanning alerts. So when you do commit a secret, it will show up in the secret scanning alert. You'll get a notification. By default, administrators and repository owners, this information is scoped to them. So if you do find a secret, you might not want an intern to join your organization and then see all your secret and token formats. Maybe that wouldn't be something that you want them to see. So what we'll do is that we'll scope it initially just to the repository owners and also for the administrators of the enterprise account or GitHub organization. We'll report them in this window. Let's just say that you did have a Terraform key that you were committing. What we'll do is we'll show you what files are impacted. And then most importantly, the developer is now aware of this. You can put this into a better mechanism. You can see what files it impacts. And then most importantly, once you have it resolved, you can mark it as revoked or false positive, or you're not going to fix it for whatever reason. Once you do that too, then we'll be able to see from the closed secret alerts what was the sort of pattern that we used to resolve this. One more important thing I want to mention is that this is always running, meaning without any additional configuration outside of just enabling it, this is constantly running, and it's running on GitHub's platform. So there's no additional configuration that you have to do per repository. And the reason why I want to mention this is this makes it very easy for enterprises to roll out, meaning that there's no additional configuration file per repository. We can enable this at the enterprise account level, at the organization level, at the repository level, and this will constantly scan. So there's some secrets, again, across the entire business that we want to be scanning for to make sure that we're catching. But also, too, some will be scoped to a specific repository. And by the way, this is something that happens or impacts pretty much every customer that I talk to, in addition to our own company, to GitHub. Our engineers are human too. We commit secrets all the time. Again, the solution really is to be checking for these things, not to think that you can hire people that don't make mistakes. So especially on a Friday, right? Okay, cool. So if you have any questions on secret scanning, please let me know in the chat, and we can take those either now or at the end. There's one other thing I want to mention too. Secret scanning and code scanning are part of our advanced security offering, which is an additional cost on top of GitHub Enterprise. If this is something that you're interested in trying, either for work or just for your own account, please let us know. We'll have AJ add a QR code at the end where you can reach out and find out some more information, or if you're interested in exploring a trial, we can also kick that off as well. Okay, cool. So now let's get into my favorite topic, which is code scanning. So GitHub made an acquisition for a company called Semel, for those of you that are familiar. This is static code analysis in a very novel way. A very quick kind of too long didn't read is that we make a database of your code base at compilation time. So we'll create a database that we can query then with these queries that we write for security vulnerabilities. So I would say, like, the more I work in security, the more I realize that it's really not magic. It's really just a lot of effort that has to be taken into writing queries against known vulnerabilities. And GitHub is a very effective approach for doing this. So we lean, in addition to our customers and our own security researchers, we also lean on the open source security community. Most of GitHub's products are free for open source, and we do that by design. First, we want to encourage everybody to be writing software and contributing to open source and just improving the quality of software everywhere, pretty much. But also, too, this helps contribute back queries that then we can execute against our code bases in private source code. So you'll see if you click around GitHub, if you go into like their branch protections and see like their pull requests and see like what are the required status checks, which we'll get into in just a little bit, we can see that people are using CodeQL to scan their code bases before they release it. I'm a big space fan, like in like personal like hobby. What's really neat too is that it's a good solution for Earth, but also too NASA uses this technology. JPL is one of our customers, and they want to make sure that they have high quality releases. A lot of customers that I talk to, they always talk about mission critical, and I say, like, what's more mission critical than like an interplanetary space mission? This stuff has to work really perfectly, asynchronously, and like Mars is like 30 light minutes away. Anyways, JPL and Ingenuity and Curiosity and Perseverance and these rovers, they use GitHub Actions to build their source code, but even more importantly, they're also scanning the quality of their code with CodeQL. Of course, the code is open source, by the way. If you ever want to go check it out and see that required status check, you could just always go into the Mars Ingenuity flight code. You could always just click into a pull request too and see like what are the required status checks. And in this case, they're doing a ton of checks. These checks, by the way, are just making sure that we're checking everything that's important to us before we allow the code to be promoted into main branch. And this will vary. Don't worry about this name here at LGTM. This is like the open source version of CodeQL that we named before, but this has now been sort of rebranded into GitHub Advanced Security, and that's why you can use it now in your repository. But you can see here that they were doing CodeQL analysis for, in this case, C and C++ and Python. Okay, so let's actually implement this and show you how you can do this within your own code base and show you how you can configure this. So what I'll do is I just have a repository here. Now, this also requires GitHub Advanced Security. So again, if you want to initiate a trial, but you can also try this today if you have a public repository. In your security tab, you'll be able to access the CodeQL scan. Again, CodeQL is free for open source. So if you want to try this today, you absolutely can. So within the security tab, within my repository, I'm going to click security, code scanning alerts, and this CodeQL analysis. Now, one really important thing to communicate about GitHub Advanced Security in general is that you should think of it more like a security hub, meaning that we can ingest results from many other third-party tools as well. A lot of folks that we talk to, yeah, they're really interested in CodeQL, but they have existing tools that they also want to see the results from. You can absolutely do that as long as that tool supports exporting a file format called Serif. Serif is just like a JSON-like type file format that we use to ingest security vulnerabilities and then provide the developers a rich experience. One thing that we focus on in advanced security is not only finding these vulnerabilities, but also we want to display rich results to the developer to actually fix them. And it really helps for all this stuff to be under one hood too. A lot of companies that I talk to, they have like security tools that dump all the vulnerability findings into some like Jira backlog, which never get addressed. And then they do like a biannual security build. What we really want to do is that we want to halt development intentionally if we detect code scanning results. But also too, we want to provide an actionable path forward for the developer. And that's exactly what this does. And that's what I want to show you here. But just to show you really quickly, I just wanted to show you that we can also pipe in other results. So, okay, what we're going to be doing is that we're going to be setting up this workflow. For those of you not familiar with what a workflow is, GitHub has its own built-in CI/CD system. This is called GitHub Actions. Under the hood, it's powered by Azure Pipelines. We provide to you Mac, Linux, and Windows computers that you can leverage. These dynamically scale up and down. With GitHub Enterprise, you and your team have 50,000 minutes to draw upon. You can also, if you don't want to use one of our hosted machines, which is provided automatically to you, you could also have a self-hosted runner as well. A simple way to think about it is that you're just adding your own computer to the build farm. And we can set this up at the organization level, at the enterprise account level, at the repository level. And you can run on your own machines for free if you like. Or you can use our machines, and we have different prices for the different machine types, with Mac being the most expensive, of course. Okay, so what we have here is a workflow file. It creates a CodeQL analysis YAML file in our .github folder. This will end up at the root of your repository, and you can have many YAML files with many different analyses and linting and everything else that you want to do. This is just a default script that we set up for you for CodeQL specifically. Just one thing really quickly, like this is a great editor. Like we'll have like built-in IntelliSense in it. So if you want to bind to any webhook or event that happens within GitHub, we can very quickly set that up. Again, we make it very easy for you to automate anything within GitHub, including CI/CD and other things. In this case, by default, we're binding to pushes, pull requests, and in this case, we're scheduling a cron job for this execute, in this case, every 5 minutes. So you can set this different threshold and trigger on different events. Okay, in this case, it looks like we're running on Ubuntu latest. The only thing that you have to change to get started, by the way, is just the language that you're scanning for. So in this case, very easily, I can just delete Python, and conveniently, we list in a code comment here in the YAML file the different languages that we support. I'll have Rob to drop into the chat what languages that CodeQL supports. We support the most popular languages. And then on the short-term roadmap, we have Ruby coming up next, and then we'll have Swift and Kotlin in the short term as well. And if there's any languages that we don't support, again, what you can do is that you can use a third-party or open-source static code analysis engine. And again, you can still pipe in the results into GitHub Advanced Security. So still bring that tool, and we can support it as long as it supports Serif. Okay, I'm just going to commit this onto a new branch. Just to show you an example of this working. I'm going to rename this file. Looks like I've already done this before. What this will do is that this will commit this file. And then now, based upon that criteria, I'm just going to create a pull request just to get this into main branch. And you can see here that we have a check that's being run. In this case, it's the CodeQL analyze phase for Python. And if we click into the details here, we can see this actually running within our CI system. So this is very simple. Again, we don't have to spin up machines. GitHub provided us the machine. We just have to click some buttons and change one parameter. Let me show you what this looks like too when this reports back results. So of course, the developer is going to be pushing code, and we can report back as soon as we execute the scan about how the quality is of their pushes. In this case, they're going to be opening up a pull request. And what we really want to do is that we want to get these code scanning results in front of the developer as quickly as we can. One thing I learned, and maybe when we first started doing this, we thought that there was some sort of like contentious relationship between security and development. And after talking with a lot of companies, what we realized is that it's not just that like a developer doesn't want to fix security things. They're very happy to fix security things. I would say like where like the contention comes from is that if a developer gets blindsided with security results, meaning that they don't know about them until they finally open up their PR and then like they're trying to go home for the weekend. And then they get blindsided by like, 80,000 security results and they can't go home. That's usually like where they get pretty angry, as would anybody. But if we are doing this as part of development, if we're doing this triggering on the push, for example, then we can bring up in our stand-up like, hey, I have 6 security things that I have to fix. And then that work sort of gets prioritized. And we've seen that be a lot more effective. So like in this sort of initiative of shifting left, it really also too helps with communication that you can get onto your own managers, into their purview that you have a lot of things to fix. And culturally, if your company cares about security, which I hope they do, they'll give you the time to fix them because, again, they'll impact our sort of end users. Okay, so what does it look like when you have a vulnerability? We can look within our pull requests here. We can see the files that have changed. People are going to be commenting, why do you add this? Or this is great. And you can see here on line 66 that we have a code scanning results. And you can get a notification for this as well to your email. But it looks like on line 66 here that we have a query built from user-controlled sources. If we show more details here, and this is really where this product shines, GitHub Advanced Security, code scanning with CodeQL, is that we're not just going to give you a single line and be like, okay, great, good luck, you should fix this, you have a major SQL injection problem. What we really want to do is that we want to give your developers a good picture of how they can fix this. Because the first thing the developer is going to do is say, okay, shoot, I have a SQL injection problem. They'll put a breakpoint on line 66 here. But because CodeQL executes a compilation time, we can already save your developer a step, and we can show them the data flow for where the string flows to the application to where it's eventually executed on the database. This is extremely useful to save your developers that extra step, and they can start to wrap their heads around what the fix is. No security fix is ever going to be a single line that you just, address just there. These fixes can be complex depending on what type of problem it is and what type of query was reported for the security vulnerability. So this is something that we're really proud of and we have seen be very effective. But even more than that, we're no strangers to SQL injection. We can also provide to you a rich fix as well. So these queries are written in the form of QL files, and these QL files contain within them recommendations that then we can offer to your developer. I also wanted to say too, what queries are we executing? We have an entire pack of default queries. As I mentioned before, these queries come from different sources. They come from open source security community. They come from GitHub and Microsoft CodeQL engineers, but also too, they also come from other companies as well. So for all our customers, including Microsoft and the Windows team, there are queries that are constantly being written against vulnerabilities that are coming out. Security is a constantly changing landscape, and tomorrow there might be another vulnerability that comes out. What's really cool about this is that you don't have to wait for some big company to write a query. In certain cases, within 24 hours, the open source security community is already posting on Twitter like a new query for a new vulnerability that just came out that we didn't know about yesterday. So we can immediately put that query into our query pack, and then we can execute it against our code base and get ahead of it. I would say what I see the most mature organizations doing is that they're very quick and dynamic to adapt to new security threats. And that's like the difference. It's not like that every company that spends a lot of money in security is completely immune. A lot of times it's just very quickly adapting and making sure that you patch your code very quickly. Because us as a software company too, we also get impacted by these security vulnerabilities, and we have to jump on them very quickly. So what I was saying here is that the recommendation is provided. We can give you an example of a bad fix, a good fix, and your developers will love this because this is an actionable path forwards. The first thing that most people will do is go to Stack Overflow or some other websites to read, like, oh shoot, I have SQL injection problem. I'm directly executing out of my database something that was user inputted. But again, we can provide a good example of a fix. Your developers can read this, and then we can provide 2 examples for why we're saying this. Don't take our word for it. If you want to read more about this, we can link you to the vulnerability links which define and explain what this bug is, why it's a problem. Your developer will go ahead and fix this. We can rescan. We can make this a required check as part of a branch protection. And we can make it so that developers can't circumvent this required status check. We've seen this be extremely effective at helping secure code bases. What we want to see over time, of course, is that we want to see the total number of vulnerabilities decrease over time. And just to show you some more code scanning alerts here too, this will all end up in your security tab. The critical ones usually have to do something with like something really bad, like arbitrary code execution. These are ones that we want to make sure that we address immediately. I would say when you're rolling this out too, initially you can perform your sort of initial scans, and then later you can make this a blocking activity. Just, because this is a demo day, I just want to show you too, if you ever want to make this a blocking activity or any required status check, we can add something called a branch protection rule. What this rule will do is this will apply to the branches. You can just have this scope to main branch or any others, is that we can require status checks to pass before merging. So like I showed you before in that Mars helicopter, which by the way is like doing great, we can add this required status check that we want to add CodeQL to this. And if we want to too, we can allow certain people to circumvent the status check, and then we can audit that activity later. Okay, great. So that is code scanning with CodeQL. Let's go back to our agenda really quickly. I want to quickly cover Dependabot, and I also want to show you the security overview as well. Okay, so within any organization where we have GitHub Advanced Security enabled, you'll see a new tab get added to your organization called Security. Big surprise. Here, like very quickly as people start to roll this out, they want to see like the state of security across GitHub. This dashboard lets you do exactly that. It lets you see which repositories have this enabled, who has code scanning, who has Dependabot, who has secret scanning. And then more importantly, we have companies that have 50,000 repositories in GitHub. So very quickly, we want to see kind of like the state of security across the business. And then we can sort it. Like we can say, okay, who has the most amount of unaddressed secret scanning alerts, for example, or code scanning alerts. And we might want to go bug those repository owners. Like here in this bookstore test, you can see that we're generating a ton of these scanning alerts. And we might want to go bug that repository owner to go ahead and go address these. Or like who has the most amount of secrets, like 15 unaddressed secrets. We should go bug that person to go put those into encrypted storage. And we added one other thing too. We can also show you across the entire business. So that means all the repositories in the organization. We can show you all the key types too. Like if you can sort of correlate like what's your top most unaddressed key, you might want to send out like a PSA to like the entire team and just be like, hey, everybody, like we have to go store these keys in encrypted storage, and like this is like the biggest offender. So you can kind of gain insight to how people are doing that there. The last thing I want to cover is with regards to open source and the open source packages that we're consuming. And I would say today we're consuming more open source than ever. It's really amazing, actually. We can do a lot by building upon the work of others. And in a lot of cases, we just don't have the time to build all the stuff that's available in open source. Your bosses will not give you time to build what exists as an open source dependency already. You can try, but it might take like months for you to do this or years. So we pull down what's sort of known and reputable, and we put it into our enterprise software and we ship it off. What I like to say is that GitHub is very close to the signal and like a good trusted advisor to make you aware of what vulnerabilities might be in there. In fact, GitHub is now a CVE numbering authority as well, where we can actually empower open source maintainers on our platform to raise new vulnerability alerts, because the code is also going to be within GitHub's platform. So again, what I like to say is that we can notify you first of any vulnerabilities that hit. And again, there are a lot of these coming in for a lot of different dependencies. One thing I'll add too is that I think a lot of people think that these open source maintainers are like big companies. And often it's very small teams that don't have a lot of resources. So they're doing their best, but sometimes vulnerabilities just end up in them. And again, they do the best to fix them. What we want to do as enterprise software developers is that we want to be very careful to make sure that we're on the correct version. And that's exactly what GitHub provides to you when you develop on our platform, is that in this case, we look at your dependency file. Here I forked VS Code. I didn't update it in like over like a year or 2 years. And we can see here that we have our open source dependencies listed with Dependabot alerts, meaning that there's a vulnerability filed against these open source dependencies that we want to make sure that we address. So we can sort by severity. The reason why I have so many, again, is just because I haven't updated this in a while. So this pretty benign thing like JavaScript array manipulation, Lodash. Well, this pretty, benign thing now is becoming a bigger issue because it looks like there are open CVEs filed against it that can be exploited. And it looks like that this version that we're on can be vulnerable to prototype pollution, which could lead to arbitrary code execution, which is really bad. What it is linked to is our GitHub advisory database. We main and curate an entire database filled with these vulnerabilities. This is increasing every day. What's really cool is that we can provide to you complete information. If you want to find out more information about this vulnerability, you can click in. We'll even give you the pull request that fixes this and the issue and where people are discussing it. This might be too much information though for most folks. So like your security team might be interested in this. A lot of developers just need to know what version they want to be on. I want to mention too that you might think that the latest version is the best version to be on always. But if you think about it, a new version can introduce new vulnerabilities. What we actually want is the most mature version that has all the open vulnerabilities filed against it resolved. So that way we have the most mature version that has everything fixed in it. And that's exactly what GitHub provides to you. Now you can change this. You can change the Dependabot configuration in a file that you include within your repository to always get the latest version if that's what you want. But by default, we'll give you the version that's most mature that has all the open CVEs filed against it address. When we first came out with this feature, we would tell everybody, like, hey, you have a major problem and like good luck. And no one did anything. To make this even easier for your developers, what we do is that we automatically open up a pull request. What we do is we bump the package version of Lodash and we change the corresponding hash. And then we just give you a PR. The more that we involve development in the security process, we found to be the most effective. It's likely that even if you work at a large enterprise, it's likely that your security team is really small. In fact, even the biggest companies in the world sometimes only have a handful of security people. That's something that I learned. But we have a lot of developers. And the more that we involve developers in this process, the better. Developers are perfectly capable of merging a pull request that bumps a package version. This is very simple to do. And it is very effective. And then we can save the security people for more complex tasks and helping writing queries and stuff like this. Okay, cool. There was one more thing I want to show you with regards to the dependency review before we stop and take some questions. Just find that tab really quickly. We added a new feature recently where if you're adding something, if you're adding open source repositories to main branch within your source code, we had something called the dependency review. What this is that in that same view that we showed before, where we're looking at the files that have changed within a pull request, we can also make you aware of new open source that's about to enter into your application. So this is really cool. This lets you know from the open source dependencies that you're adding, we kind of give you like a sneak peek about like what's going on. Meaning is that the open source dependency that you're about to add to your software doesn't contain high severity vulnerabilities. This is something that would be interesting to you if you were about to add this package version. So what you might want to do based upon this information is not add it or add the version that addresses this vulnerability. But again, just another sort of level of oversight that GitHub is providing to you to make sure that for this new code that's trying to enter into production, that you're aware of what might be in it. And again, you can see here that there are vulnerabilities over the place for these versions that we want to add. So you might want to act upon this and change the version of the package that you're about to add into production. And then so that way that you're actually safe from this. This is another feature that's included with GitHub Advanced Security. We'll make sure too that that you get the link in case you're interested in starting a trial of GitHub Advanced Security. I'm going to stop sharing for a moment just so that we can see the questions and we can start to address them there. So Rob, I don't know if you want to share with me the questions that you saw, or if I just read through the chat here.
There was one around, does Dependabot apply to Copilot? But I believe they're independent.
Yeah, so let me just explain what Copilot is and how Dependabot is different. So Copilot, we partnered with OpenAI to, the way that you could think about it is that like we're applying machine learning and generational neural nets in order to do some like advanced code completion. So right now that's a beta feature. And if you just, I don't know if you can pop the link into the channel there. If you did want to get early access to Copilot, you absolutely can. It runs within VS Code, of course. And right now, those are separate kind of products. What we do with Dependabot, of course, is that we're looking at your dependency file of your application. We'll scan to see like what's in your log file or manifest file, whatever it may be. And then based upon that, we'll compare that to our databases of known vulnerabilities filed against those open source dependencies. And then again, we'll open that automated security fix in the form of a pull request. And then you can go ahead and merge that. Copilot is a completely separate product where we're essentially doing advanced code completion and generation for any software that you're writing. And I know that we had a pretty lively Hacker News post about this. Again, if anybody wants to try this and try this out, please go for it. But yeah, they do separate things, Rob, in general. But yeah, great question.
Yeah, I see a question from a bit earlier from Peter Corliss. He says, what sorts of tools does GitHub have for malware commit analysis? A lot of dev teams cannot do their own malware analysis on commits. Seems like this needs to be free and offered broadly for the safety of all repos.
Yeah, that's a great question. That's a broad concept too, like malware, because that could be interpreted in different ways. In general, as we start to see more vulnerabilities, and CVEs and CWEs and NVDs are filed against these vulnerabilities, including malware, things like Solarigate. What we'll do is that we'll update the queries to handle these. Okay, so let's just take one example. Like malware, like Solarigate. We can drop into the channel, but here, I'll reshare my screen here. So this is a constantly changing landscape. And again, we don't really know what's going to come out tomorrow. Like, we would love to know that. And if anybody knows, please let me know. But more importantly, everybody gets blindsided by this at one point or another. What we want to do is that we want to very quickly adapt. In short, I'm getting to answer your question. In short, we update our queries, which we then modify our default query packs, which we then use CodeQL to scan our code bases. These get pretty sophisticated too. Like, we want to share this article, how GitHub and Microsoft released and open source all the queries for CodeQL. Again, this is something that impacts us as a major software developer. And what we can do is that we can leverage CodeQL to find these things. So you asked the question, like, how can we help protect ourselves against malware? Well, these are pretty sophisticated things that are happening these days. Like, now that we're getting really good at kind of patching these security and finding these, we kind of have to up our game on the security end too, as these hacks get more sophisticated. And in this one in particular, you might not have found it at all if all you did was look at text. But given the unique way that CodeQL generates this database at compilation time, we can actually look at the delta between what is happening at compilation time and what's in the source code. And in the case of SolarWinds, what was happening is that there was, at compile time, there was injection of malicious code. Again, what we can do then, now that we know about it, is that we can scan for it. We'll share a link that we open source all the CodeQL queries that we can use to determine this maliciously injected code that happened at compilation time. This gets added to our offering. And again, what we can do is now we can scan our code bases for it moving forwards. So depending on what the malware is and depending on what was happening there, we'll write a query against it, and then we can scan for it moving forwards. I want to mention too that if you have anything that is specific to your code base, or if you have anything that's a problem for your organization specifically, we can also augment the default queries that are provided with CodeQL by writing it ourselves. This is something that your security team can do. In this case, we can use like the VS Code extension for CodeQL, and we can write different queries for custom things that might happen within our code base. Of course, there's things that can be generically applied, like we're all impacted by this vulnerability or by this malware. But of course, there will be code quality issues and things that we want to fix with the things that are specific to our code bases. By the way, this includes Microsoft and GitHub and every other major software company. is that you'll have things that are specific to you. You can author these queries locally. You can execute them against a database that we create from your code base. The results will be posted here. This is mostly what the security team will be doing as opposed to the developers. But if any developers are feeling savvy enough, you can absolutely use this engine as well. In fact, I was just talking to an engineer that uses this same mechanism, this CodeQL mechanism, not to find necessarily security things, but just to scan their source code. Again, it's like kind of like using a SQL language to scan your code base. And if you're doing your own code review, or if you want to find out from your own sort of like research, not even security things, but you can also just search your code base using this for certain things that you want to find. But yeah, this is what we use in order to write the queries and to determine their efficacy. And then, of course, once we're satisfied with what this query is doing, then we can add it to our default packs and make sure that we're scanning our code bases moving forwards. So now that was a long answer. It was a good question. And hopefully that was useful.
Cool. Thanks, Glenn. We have another question from Dominic. He says, what about nested dependencies in the OS dependency reviews? Would those be reported as well?
Yep, great question. So yeah, I think like people think sometimes that like open source software is not like software. What I mean by that is open source software relies on open source software too. So it's what we call like a subdependency or transitive dependency. So the answer is yes. If down the, it's dependencies all the way down, it's like recursive. That the open source library that you're pulling into your application is also going to contain open source. And then guess what? That dependency also has the dependencies or a series of dependencies. And again, you can build this tree that goes like all the way down and its dependencies all the way down. So yes, we can inform you that if a vulnerable dependency gets wrapped up into a direct dependency, we can notify you that as well, that you have a vulnerability there. And I would say we can drop into the chat as well if you want to see the list of manifests that we support and dependency files. We'll also make sure that we leave that into the chat there as well. So the answer is yes.
All right, Glenn, I think we've come to the end of our question and answer period, but thanks so much for being really thorough and showing some very straightforward steps that developers can take to help impact the security of their applications. If folks want to dive deeper into this topic, like what's the best way for them to either continue the conversation or ask more questions?
Yeah, absolutely. So you can always just email Rob or I, maybe me, I don't want to give Rob's email address. Or you could use the QR code that we just displayed that AJ had up if you just want to reach out and find out more. A lot of things I showed you, again, were covered at our advanced security offering. So we'll have to set you up with a trial if you want to do that in private source. Just be mindful, if you're an open source developer, you can leverage code scanning in a public repository, but not the other features I showed you, like private secret scanning in addition to the dependency review. But again, if you want to try this stuff out, just contact us via this QR code, and we'd be happy to set you up with a trial.
Awesome. Thanks again, Glenn. I appreciate it. And Rob, you too in the chat. Thanks for helping out today. And we'll see you soon.
Yeah, thanks all. Have a great Friday.
And just another reminder, GitHub Universe is coming up at the end of October, completely free. All you need to do is go to githubuniverse.com and register. There's going to be 2 hours of live sessions over 2 days, as well as a lot of amazing on-demand content. So, you don't have to necessarily plan your entire calendar to catch things when you need to catch them. But if you do want to see what we're going to be releasing, the latest news and all sorts of special fun stuff that is top secret right now, go ahead and hit that up. In any case, I will see you at the next demo days. Thanks for joining us today, and thanks everyone in chat. Always good to see you and hear from you, and see you in the next one.